My name is Kelsey Young, and I'm a planetary scientist at the NASA Goddard Space Flight Center. And so switching gears a little bit, we're going to talk about the moon for the next few minutes. And so what we're going to do is talk about the Lunar Reconnaissance Orbiter, which is one of NASA's spacecrafts orbiting the moon right now. And we're also going to talk about how that Lunar Reconnaissance Orbiter spacecraft pertains to NASA's Artemis program, which is NASA's plan right now to put the first woman and the next man on the lunar surface. So what we want to do first, if we could start this video over, is take sort of a tour of the moon. The reason for doing that is kind of highlighting NASA's LRO, or Lunar Reconnaissance Orbiter spacecraft, which has been orbiting the moon now for over a decade, collecting data from a number of different instrument suites. So we're going to, through the lens of those different instruments on the LRO spacecraft, take a look at what we're able to learn on the moon now as we prepare to put people and boots on the ground back on the lunar surface. It's a really exciting time to be a lunar geologist. So sort of our first stop on the tour is the Oriental Impact Basin. So this is a really compelling impact crater feature that we can learn a lot about through the lens of this GRAIL data set, or a data set looking at the gravity of the lunar surface. So we can actually peer through the subset and look at that gravity information, which can help us prepare for human spaceflight on the lunar surface. We're now continuing on our tour to the lunar South Pole, which is where we're going to be sending astronauts as a part of the Artemis program. And those highlighted areas are actually areas where we think there might be water ice on the lunar surface, which is where we want to send humans to look at how to use that ice to potentially stay long term. So we're kind of zooming into the South Pole here, and this is a really exciting time because hopefully we're going to have astronauts walking around in Shackleton Crater or nearby on the South Pole of the moon. But we're zooming back away. We're going to return to talk about the South Pole later in this talk as we, again, prepare for that Artemis program. So what you're seeing here is, again, just like Oriental, we're seeing big impact craters, and the biggest of them all is the South Pole Aitken Basin on the lunar far side. We don't know the exact age of this structure, but it's a really high priority science objective for when we go back to the lunar surface. So we're now continuing to spin around, moving away from the South Pole, even though we'll be going back with humans soon. And we're going to zoom in on another really compelling structure here. A lot of lunar science focuses on impact cratering and volcanology, and one of those big impact craters right here is the Tycho structure. The LRO spacecraft affords us really high-resolution pictures of the lunar surface, which is great for when we're preparing to send humans back to the surface. And to give you a sense for how high-resolution it is, that boulder right there on the top of that central peak is 100 meters across, and we're able to get really crisp resolution on it. And those images are great for science, and they're also great to prep for human exploration. Continuing on, we're going to head to a more volcanic feature called Aristarchus Plateau, where we see, yes, impact craters, but also some volcanic deposits as well. This has long been a really compelling science target for lunar science. We have a lot left to learn about that. And through instrumentation on the LRO spacecraft, it can give us a sense for what that surface is made out of, and we can start to pick apart how these landscapes form. But it's not just kind of going forward, it's also learning a lot about where we've already been. We've learned a lot about lunar science in the last decade and the last decades. And one example of that is zooming in on where humans have been on the lunar surface. And one of those places is the Taurus-Littrow Valley, which is where astronauts explored the lunar surface through the Apollo 17 mission. So what you'll see here is data from the LRO spacecraft so high you can actually see the traverses that the Apollo astronauts took on the moon. You see their 3 EVAs, or spacewalks, that they took here. And zooming in even further, I love this. You can actually see the lander where the astronauts landed and of course left their landing stage there. And as you traverse over here, you can actually see the rover, which is what the astronauts use to, of course, drive around and explore on the lunar surface. We're hopefully going to be doing this again really, really soon. And one of our last stops on the tour is actually heading up. We've been to the South Pole. Now we're heading to the North Pole. And the North Pole is also a really compelling science target. We have a lot to learn about potentially using volatiles we might find there for in situ resource utilization. And so you can see there's a lot of compelling science to be left on the moon. And the Lunar Reconnaissance Orbiter is a great way that can tell us about what to expect through its whole host of diverse set of instruments. So we'll continue on here. This is actually a crater on the lunar far side, and this is actually a data set that was taken before the Lunar Reconnaissance Orbiter got to the moon. So you can see it's pretty fuzzy. We really didn't have crisp data. This is interesting scientifically, right? Lunar Reconnaissance Orbiter gave us a lot in terms of the resolution of data we have on the moon, but think about planning a mission to the moon with people with data sets like these. It's really the data obtained by the Lunar Reconnaissance Orbiter that enables us to plan for NASA's Artemis program. Here is a picture of the same exact spot on the lunar surface with the data obtained with the Lunar Reconnaissance Orbiter spacecraft. So just to flip back and forth there, the LRO spacecraft enables us to answer these high priority science questions like the age of the South Pole Aitken Basin and allow us to also prepare for when we're going to want to send people there. It can also not just give us this great visual imagery, but other missions we've sent to the lunar surface can allow us to peer beneath the surface. So while we want to use these photos and images to design traverse plans and to answer science questions, we also want to probe beneath the surface. And the GRAIL mission actually enabled us to get a look at the gravity of the lunar surface, which helps us understand how that moon evolved and also where it's going in the future. So here is actually a look at the Apollo 11 mission. We just passed the 50th anniversary of that mission. You can actually see each kind of stage of that mission there. And actually you can even see the boot tracks that Neil Armstrong took on the lunar surface. This really allows us to place the scientific samples, the geology samples, in even greater context than we ever had before, and allow us to really get a look at where they sampled. And here's a great example of looking at the traverse that Neil Armstrong and Buzz Aldrin took. We're able to take those Apollo 11 samples and understand even more about them now that we know exactly where they went and exactly what the context of those samples are. So you're able to see the crater that Neil Armstrong and Buzz Aldrin actually had to change last minute their landing site because they had to skim right over the rim of that crater that they didn't know was there because they didn't have data that like we're looking at right now. So just to give you another sense of the type of data that LRO is able to collect, obviously what you're noticing here is changing in the middle of the screen there. You see a bright flash and sort of a white spot appear on the image. That's actually a new impact crater that formed since the lifetime of the Lunar Reconnaissance Orbiter orbiting the moon. So the first time it took a picture of this area, that crater was not there. The next time it imaged that area, the crater was there. What this is telling us is, in many ways, the moon is still an active place. There are surface processes that are changing the surface of this, our nearest celestial neighbor, in observable time. And we've observed hundreds of these new impact craters forming in the 10 plus years that LRO has been at the moon. And what does this tell us? Well, space is still an active place. Also, you don't want to be an astronaut that was standing right underneath where that object hit the surface of the moon, right? So it's helping us to predict how often these small impact craters are formed on the lunar surface. And it also tells us something about the cratering process, as well as how to prepare for the type of hardware we want to design to explore the lunar surface. So the moon is a really dynamic place. The Lunar Reconnaissance Orbiter is helping us explore that. Here, once again, is the Taurus-Littrow Valley. So again, this is the site where the Apollo 17 mission visited the moon. This is the last time we had astronauts on the moon. And one thing I kind of want to emphasize today is, this is the last time we've put boots on the ground on the lunar surface. As I mentioned earlier, NASA's Artemis program is seeking to bring them back. In fact, today is NASA's Artemis Day. I'm not sure if you guys saw that on social media or anything. NASA's Artemis Day is kind of a way to bring attention to the Artemis program, but what really happened today is the first time that the core stage of the SLS rocket was assembled at the Michoud NASA Center down near New Orleans. So today is NASA Day, and why, or excuse me, today is NASA's Artemis Day, and why do we have Artemis Day? Well, again, I think this is a great place to talk about it. This is the last time we've had people on the moon, and today a really big step was just taken to bring us back. And so with that lens in mind, here is a picture, boots on the ground, from that Taurus-Littrow Valley Apollo 17 landing site. So we just saw a picture taken from one of the cameras on the Lunar Reconnaissance Orbiter spacecraft. And here is a picture taken from the ground. This is astronaut Jack Schmidt taking a sample on the lunar surface. On the left side there, you'll see the Lunar roving vehicle. This is a small rover that the astronauts were able to use to travel even greater distances away from their landing site, as well as to store samples and store sampling equipment. I do a lot of field work here on Earth. I'm a field geologist by training. I would love to have a roving field assistant that would come with me on all my field work to be able to carry all of my equipment, and especially those heavy rocks once I pick them up. So we learned a lot from this mission. We learned a lot from all the Apollo missions. We especially learned a lot from Apollo 17. That guy right there, Jack Schmidt, was a geologist prior to becoming an astronaut. So we actually put a scientist on the moon in this mission. We learned a lot about how to sample on the moon. Actually, if you head over to that NASA booth later, you can actually see some of the hardware that we were able to, not the exact hardware, that's in museums, but mock-ups of the tools that we were able to use on the lunar surface in Apollo. And it was really, these missions that taught us a lot about the properties of the lunar surface. And I can tell you that right now we're taking a lot of these lessons learned that these astronauts taught us, and we're applying them to where we're going with the Artemis program. So this is kind of a movie showing illumination conditions at the lunar South Pole. Again, NASA's Artemis program is going to put the first woman and the next man on the lunar surface, and we're going to the South Pole. So while we don't know exactly the X marks the spot on the lunar surface where these astronauts are going, we do know that it'll be near the South Pole. And what these data are showing you is actually the illumination conditions at the pole. And so you can see that we're marching through the year 2024 down here. And 2024 is the year that we've been charged with for when we want to put these astronauts on the surface. And so what you're seeing here is kind of a time lapse of what it will look like in terms of illumination when we are able to put astronauts on the lunar surface. So just for a minute, picture that you're one of those astronauts. You're landing on the lunar surface. You want to do geology. You want to plant the flag. You want to learn about all of these science questions that we've talked about, that we're learning a lot about from the Lunar Reconnaissance Orbiter. The lighting conditions at the pole, just given orbital dynamics and where the moon is versus the sun, make it pretty complex to work at the South Pole. Lighting can be a challenge. Even in the Apollo missions, the astronauts noted that the sort of semi-oblique lighting angles that they were working with made it hard to judge distance. They couldn't tell how far they were from a site of interest. They knew that the crater rim they wanted to reach was just over there, but it looked a lot shorter than the distance actually was, just because of the way the light was playing over their landing site versus the lighting they're used to operating in on the Earth's surface in training. The South Pole is a different beast. It's even more complex. Illumination will be a challenge. We're working on right now what kind of challenge that will be, how to train the astronauts to prepare them for that challenge, how to make sure the hardware can withstand that challenge. And I really love this image because right now scientists are preparing for how to do science in these illumination conditions, but more importantly, the operators who are designing rover hardware and spacesuit hardware and training the astronauts in how to operate in those conditions are looking at visuals just like this to prepare us for what that exploration is going to look like. So next time you're kind of outside, if you do field work or even if you just go on a hike, imagine trying to do that and execute your traverse plan in these really, really variable lighting conditions. And I really just want to stress that the Lunar Reconnaissance Orbiter is the spacecraft that's really enabled us to get these really great data sets that help tell us, hey, there's a lot of science left to learn on the moon. We've gone back and looked at the Apollo landing sites in a lot greater detail and understood the samples that those astronauts collected and placed them in even a higher resolution context than we ever had before. And I'm a geologist who thinks about science integration into human spaceflight. So I care a lot about field geology, and I especially care about doing field geology on the moon. And so here we are training astronauts, designing hardware, designing sampling and science hardware, in situ analytical hardware, but also the hardware that's going to keep our astronauts alive in terms of rover, spacesuit technology, sampling technology, and it's these kind of data sets that are going to help get us there. So again, just to reflect back, we've seen a lot of amazing imagery of the moon, amazing data from the moon. The Lunar Reconnaissance Orbiter spacecraft is kind of what's helping us get there. But we're looking forward to the future, and that's the Artemis program. Like I mentioned, today is Artemis Day, and again, that means that the SLS rocket, or the rocket that's going to launch astronauts that will one day explore the moon, has had its core stage assembled for the first time. So what that means is this is a massive, many years in the making step that really gets us one huge leap forward in putting humans back on the moon on the Artemis program. And one thing we want to talk about too is that the moon is just the first step. There's a lot left to be learned, and of course the ultimate goal is right up here in the corner of the screen. We're focusing on the moon now, but all of this is to one day get humans to Mars and get more spacecraft to Mars. And so it's an exciting time to be at NASA, and it's certainly an exciting time to reflect back on the moon. We really kind of demonstrated 2019 has been the year of the moon with the 50th anniversary of the Apollo mission, but I think it's time to look forward to the future, and the future is kind of right here.